A recent NASA ESA Hubble Space Telescope image captures what appears to be one very bright and bizarre galaxy, but is actually the result of a pair of spiral galaxies, like our own Milky Way, smashing together at incredible speeds. This object was a target of Hubble's and a handful of its sibling spacecraft as part of a massive, comprehensive sky survey called GOALS.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Hi, and welcome to the Hubblecast. This new image of NGC 2623, which is located in the constellation of Cancer, was taken by Hubble's Advanced Camera for Surveys, or ACS, before the recent Hubble servicing mission. Once two distinct galaxies, NGC 2623 is a nearly complete merger, with elements of both original galaxies affecting its appearance and behavior. Colliding galaxies engage in a powerful exchange of material. They literally throw matter and gas toward one another as they race together. Stretching out from the center of NGC 2623 are two tidal tails of young stars, showing that a merger has taken place. The dramatic exchange of mass and gases initiates star formation, seen there in both the tails. The prominent lower tail is richly populated with bright star clusters. These star clusters may have formed as part of a loop of stretched material associated with the northern tail, or they may have formed from debris falling back onto the nucleus. In addition to this active star-forming region, both galactic arms harbor very young stars in the early stages of their evolutionary journey. The core, or nucleus, of this merged galaxy is exceedingly bright. Often these mergers, including this case, result in an active galactic nucleus, where one of the supermassive black holes found at the centers of the two original galaxies is stirred into action. Matter is pulled toward the black hole, forming an accretion disk. The energy released by the frenzied motion heats up the disk, causing it to emit across a wide range of the electromagnetic spectrum. Although rare in our solar neck of the woods, extremely bright galaxies like NGC 2623 exist at higher redshifts, or, in other words, at an earlier stage of the universe's evolution when these systems were dominant. Their brightness signals furious activity, new star formation and a rambunctious core. The aim of the GOALS project is to use the combined powers of multiple space telescopes to characterize their local counterparts and give us clues as to what is happening in more distant galaxies while educating us about galaxy formation. Each telescope in the GOALS project brings different strengths. Hubble's incredible resolution in the visible allows us to scrutinize the galaxy's morphology or structure. In these images, astronomers can determine the stage of the merger. For example, has the union produced tidal tails? Have the individual galaxies' cores melded together as one? Chandra's X-ray capabilities allow the astronomers to detect the flurry of activity around the black holes and to monitor new star formation. Spitzer contributes in the infrared, penetrating dust, allowing astronomers to see what lurks behind the eerie dust lanes. GALEX is powerful in the ultraviolet, gathering the light of developing stars. Data from ESA's X-ray Multi-Mirror Telescope, or XMM Newton, also helped astronomers gain more information about NGC 2623. The joint efforts of these powerful observing facilities have provided a clearer picture of these standout galaxies. Galaxy evolution is a hot topic in astronomy because it is fundamental to our understanding of the universe. Studying merging galaxies such as NGC 2623 allows astronomers to witness the shaping of new, combined galaxies and the subsequent birth of stars. This could even provide essential information about our own Milky Way, that has cannibalized other small galaxies and could, one day, collide with our neighbor, the Andromeda Galaxy. This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations. For the first time since astronauts visited it in May, Hubble is opening its upgraded eyes. Brand new and repaired instruments have facilitated a spectacular reveal of the observatory's new capabilities. The moment many have been waiting for has arrived. Hubble is back and better than ever.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome back to the Hubblecast. As I'm sure some of you have noticed, we haven't seen any new images coming from our favorite telescope lately. Now that's of course because in May 2009, 7 daring astronauts spent 30 spacewalking hours repairing Hubble and replacing some of its instruments. Now Hubble is of course unique in that it is the only space telescope that can be serviced by humans, and the astronauts really made the most of their last visit. Now the fruits of their labor are finally ready for everyone to see. In this episode, we're going to show you Hubble's first observations after the servicing mission. The new images show us a bunch of different astrophysical phenomena, ranging from a bug-like planetary nebula to one of these huge galaxy clusters that act like a cosmic magnifying glass.
When new instruments are brought from Earth to Hubble, they need a chance to eliminate any trapped gases that could cause interference with their performance. This is a process called outgassing. Once that procedure is complete, scientists work with engineers to ensure that instruments are properly calibrated, so the quality of the data is top-notch.
After an incredible 16 years of service, the much celebrated WIFPIC 2, or Wide Field Planetary Camera 2, has now finally been retired. Instead, we now have WIFC 3, the Wide Field Camera 3. This new camera has imaged a stellar jet about 7,500 light-years away in the Carina Nebula. What is going on here is that we have an infant star about 8 times as massive as the Sun, which is causing quite a stir. What the WIFC 3 image reveals is a pillar of gas, and it's at the center of this gas cloud that the young star is forming. Now the star is surrounded by swirling gas and dust, and some of this material is being pulled into the star by its gravity. As a result of this tumultuous process, a jet is formed, and the interaction of this jet causes shockwaves and intense heat, which ionizes the surrounding gas, thus causing it to glow.
Truly the most powerful camera ever sent into space, the new WIFC 3's capabilities in both the visible and the infrared are an unbeatable combination and complement Hubble's other instruments, especially the advanced camera for surveys. Moving from visible to infrared, in the image of the Carina Nebula, we see the nebulosity fade and the baby star and its emission jets are revealed. WIFC 3's impressive infrared capability reveals hundreds of stars and the jet itself, hidden behind the dust and gas.
Stephan's quintet is a stunning collection of 5 galaxies. 4 of these galaxies' destinies are literally bound together. As they crash into each other at breakneck speed, gas is ripped from the galaxies and produces the distinctive tidal tails. Now, astronomers believe that galaxy mergers like we see here are one of the key processes by which galaxies can grow and evolve. And so studying mergers can help us understand what shapes many of the galaxies that we see around us today.
The new WIFC 3 camera's detector is highly sensitive and, paired with the camera's wide field of view, it improves Hubble's discovery power by 20 to 35 times. The wide field of view and clear resolution of WIFC 3 will enable forensic searches that lead to clues about the collisions and mergers between galaxies, as seen in the beautiful swirling chaos of Stephan's quintet.
WIFC 3 has also zoomed in on one very hot cosmic bug. NGC 6302 is a planetary nebula that is better known